Hi everyone. In this section, we are going to talk about inferences for two population means using independent samples. Here we assume that standard deviations are equal. In this section, we are going to compare two population means when the two samples are independent. Here we have two specific assumptions. First one is standard deviation of population 1 and the standard deviation of population 2 are equal. But keep it in your mind, standard deviations are unknown. Second assumption is populations are normal distributed. These two assumptions are really important. Now, let's see how we define null hypothesis and alternative hypothesis for our test. Null hypothesis we denote H naught is mu1 equal to mu2. We call this null hypothesis. Versus HA we call alternative hypothesis. We have three different options for alternative hypothesis and it based on your question. So one outcome is HA is mu1 not equal mu2. The other one is mu1 greater than mu2 and the last one is mu1 less than mu2. So altogether we call this alternative hypothesis and one of these alternative hypotheses you can use related to your question. Okay, now we have to define test statistic to perform our test. If you remember that we have standardized version of x1 bar minus x2 bar, we call it z equal x1 bar minus x2 bar minus mu1 minus mu2 divide by square root of sigma 1 squared over n1 plus sigma 2 squared over n2. If standard deviation of two populations are equal, we can write down it like sigma 1 squared equals sigma 2 squared equal sigma squared. So we can replace this sigma 1 squared and sigma 2 squared by using sigma squared so that we have this c equal x1 bar minus x2 bar minus mu1 minus mu2 divided by sigma times square root of 1 over n1 plus 1 over n2. Since the population standard deviation sigma is unknown, we must use sample information to estimate population standard deviation. The sample estimate is called pooled sample standard deviation. This pooled sample standard deviation we denote using S and subscript P. We call this SP equals square root of n1 minus 1 times s1 squared plus n2 minus 1 times s2 squared divided by n1 plus n2 minus 2. Here n1 is sample 1 size, n2 is sample 2 size. Replacing sigma with its estimate which is SP, we can get pool t-test which is t equal x1 bar minus x2 bar minus mu1 minus mu2 over sp times square root of 1 over n1 plus 1 over n2. We call this pool t-test has t distribution with degree of freedom n1 plus n2 minus 2. Under null hypothesis, we can write our test statistic t equal x1 bar minus x2 bar over sp times square root of 1 over n1 plus 1 over n2. If you remember that under null hypothesis, h naught is mu1 equal mu2, so that this term is equal to 0. That's why we don't have that term mu1 minus mu2 in our test statistic here. So pool t-test. How we perform this pool t-test? In the first place, we have few assumptions. First assumption is simple random sample. The sample should be independent and this population should be normally distributed, or we can approximate it if it is large enough sample. These populations has they have equal standard deviation. So now what is our test statistic? It is t equal x1 bar minus x2 over sp times 1 over n1 plus 1 over n2. To perform this pool t-test, we have two specific approaches. First one we call critical value approach. Next one we call uh, p-value approach. First, we are talking about critical value approach. In this approach, first we state our null hypothesis and alternative hypothesis, then decide the significant level alpha, compute the test statistic using our equation, which is t equal x1 bar minus x2 bar over sp times square root of 1 over n1 plus 1 over n2. Then we have to find the critical value using t table with degree of freedom, which is n1 plus n2 minus 2 with given significant level alpha. If we have left tail test, which means our alternative hypothesis is mu1 less than mu2, we have to find negative t alpha and we call if negative t alpha greater than t, we reject H naught. Here t alpha is the critical value. So our t value is less than t alpha value, we reject our null hypothesis, as you can see in this picture. Next one is if right tail test, we have to find t alpha, and if t value greater than this critical value t alpha, again we reject H naught. As you can see in this picture, t value greater than t alpha value, so we reject H naught. Last one is if two tail test, we have to find negative t alpha over 2 and t alpha over 2. We have to find two regions. If t greater than t alpha over 2 or t less than negative t alpha over 2, then we reject our H naught or we reject our null hypothesis. Next one is p-value approach. Same as the critical value approach. First we state our null hypothesis and alternative hypothesis, then decide the significant level alpha, then compute the test statistic t equal x1 bar minus x2 bar over sp times 1 over n1 sp times square root of 1 over n1 plus 1 over n2. Same thing what we have done in our critical value approach. Then we have to find the p-value, or we call probability value, using our t table with degree of freedom, which is n1 plus n2 minus 2, and calculate the test statistic, which is t. If left tail test, we have to find the p-value, so this is our p-value. If right tail test, we have to again find the p-value. This is the p-value. Remember that this p-value is the probability value, so we mention in area, so this is the p-value. If we have two tail test, then we have to find these two regions. P-value equal 2 times this table value because these two areas are equal. T distribution is symmetric distribution. In this case, we reject our null hypothesis if this p value is less than our significant value alpha. Okay, now let's see an example. This example says that study was done on relation of sex and sense of direction to spatial orientation in an unfamiliar environment. 31 male and 31 female students were selected and taken to unfamiliar wooded park and gave some spatial orientation test and pointing error was measured. At 10% significant level, do the data provide sufficient evidence to conclude that on average male have low error on direction than female? Okay, in this example, they have given what is x1 bar, it is 37.6, x2 bar, it is 55.8, s1 is 38.5 and s2 48.3. This red color information related to sample 2 and population 2. This blue color information based on population 1 and sample 1. Okay, using critical value approach, how we do this? Step 1, first we have to mention what is my mu1 and what is my mu2. That's really important. So I'm considering my mu1 is population mean error of male, mu2 is population mean error of female. Then I define my null hypothesis and alternative hypothesis. H naught is mu1 equal mu2 and my alternative hypothesis is mu1 less than mu2. Next step, define significant level. They have given 10% significant level, which means my alpha equals 0.1. Step 3 is to find this SP using this giant equation. So I know what is N1, I know what is N2. So using this equation, which is SP equal N1 minus 1 times S1 squared plus N2 minus 1 times S2 squared over N1 plus N2 minus 2 all together square root, we can plug our values N1, N2, S1 squared and S2 squared as well. Then we have a value SP equal 43.68. Next, we need to calculate the test statistic. So T equal x1 bar minus x2 bar over SP times square root of 1 over n1 plus 1 over n2. Plug the values x1 bar, x2 bar, n1, n2 and SP. Then we have test statistic value T equal negative 1.641. Step 4, we need to find the critical value. To do that, we need the degree of freedom, which is n1 plus n2 minus 2, 31 plus 31 minus 2 is 60. So we can go to the table and find this value T. Significant level is 0.1, degree of freedom is 60. According to those values, we can find the table value, which is negative 1.296. If in any case you cannot find the exact value from the table, then you have to get the values that are closest to that value. Okay, step 5. Since we have found T value and T alpha value, we can compare those two values. You can see here negative 1.641 is less than negative 1.296. So we can say that we have to reject H naught. At 10% significant level, we have enough evidence to say that on average male have low error on direction than female. So this is our conclusion. This conclusion is really important at the end of the solution. Okay. Now let's see how we can find the same problem, how we can solve the same problem by using p-value approach. Few steps are same as the critical value approach. We need to first step we need to define the mu1 and mu2. Mu1 is population mean error of male, mu2 is population mean error of female. Null hypothesis is mu1 equal mu2 and alternative hypothesis is mu1 less than mu2. Define the significant level, which is alpha equals 0.1. Step 3, calculate the SP using this same giant equation. So we have that value 43.68. Then we have to calculate the test statistic using this t equal x1 bar minus x2 bar divided by SP times the square root of 1 over n1 plus 1 over n2. We have the same value what we have taken last time, negative 1.641. Now we have to calculate p-value using t-table. We know our degree of freedom is 60. So since this is mu1 less than mu2, it is left tail test. So p-value is in between 0.05 and 0.1. So p-value is somewhere here. Our value is negative 1.641. So what we have to do? Since p-value is less than 0.1, we have to reject H0. We call this at 10% significant level, we have enough evidence to say that on average male have low error on direction than female. As you can see, if we although we use critical value approach or p-value approach, we have same answer. So next, confidence intervals for the difference between the means of two populations with equal standard deviation. Now we are going to find the confidence interval. Here also we have few assumptions. Simple random sample should be independent, normal population or large enough samples, equal population standard deviation. So we can calculate the confidence interval for mu1 minus mu2 by using x1 bar minus x2 bar plus or minus t alpha over 2 times sp times square root of 1 over n1 plus 1 over n2. Keep in your mind, if we in any case, if we need to find the confidence interval, always we use alpha divided by 2. So find the 90% confidence interval for mean error, difference for male and female based on the above example what we have done. So according to that example, alpha is 10%, which means 0.1. We have to divide by 2, which means 0.05. So now we have to find the value t, 0.05, which is alpha, and degree of freedom means 60. So the value is 1.671. Plug the values into that equation. X1 bar is 37.6 minus x2 bar is 55.8 plus or minus. T value is 1.671 times SP value is 43.68. Square root of 1 over n1 is 31. 1 plus 1 over n2 is 31. So at the end, when you simplify this, you will be having negative 36.4 and 0.65. This is the lower bound. This is the upper bound of this interval. So 90% confidence interval for mean error difference for male and female is negative 36.4 to 0.65. This is our conclusion based on the 90% confidence interval for mean error difference for male and female.